Hello friends, in this video let's have a look at the concept of permutations and combinations. This is one of the most important areas as far as competitive examinations are concerned. And for you to excel in a chapter like probability, you have to be good at permutations and combinations. This is the key for probability as well. Now let's start with permutations and combinations. For you to enter into this chapter, you need to know some very basic things. Let me cover those things first. Then I'll take you to concepts one by one. First, let me show you the very basics that you must be aware of in order to enter into permutations and combinations chapter. The very first thing that you should be good at is concept of factorial notation, factorial representation. This is the first thing that you should focus on. So, for any number n greater than or equal to 1, where n is greater than or equal to 1, right? It need not be greater, it can be equal also. For any n greater than or equal to 1, factorial of a number is defined as the product of first n natural numbers starting from 1. So, if you want n factorial, that goes on like this, n into n minus 1 into n minus 2, we will write it up to 1. Starting from 1, we go up to n, is n factorial. So, this can also be written as, if I start with n, that will be called as n factorial. If I start with n minus 1, that is called as n minus 1 factorial. Further, I can also write this as n into n minus 1 into this portion, n minus 2 up to 1 is called as n minus 2 factorial. That is n minus 2 factorial. Keep this in mind. Now, say for example, you are having something like this. If you have 5 factorial, 5 factorial is nothing but start with 5, go up to 1. That's what we mean by 5 into 4 into 3 into 2 into 1. That is 5 factorial. This can also be written as 5 factorial. This is 5 into 4 factorial. This can also be written as 5 into 4 into, this is 3 to 1. That is 3 factorial. 3 factorial. So 4 up to 1 is called as 4 factorial. This is 5 into 4, 3 to 1 is called as 3 factorial, and so on. So keep this in mind. So like this we can write it to any extent depending on our requirement. Keep this in mind. So 5 into 4 into 3 into the 2 into 1 can be written as 2 factorial if needed. And please remember, 0 factorial is predefined as 1. Predefined as 1. So, for any n greater than or equal to 1, this is the formula. But if it comes to 0 factorial, that is predefined as 1. And factorial of a negative number is not defined. Factorial of a negative number is not defined. Keep this in mind. Now, going ahead with 1 factorial is 1. 2 factorial is 2 into 1. The 2 into 1 is nothing but 2 only. 3 factorial is 3 into 2 into 1, that is equal to 6. 4 factorial, that is 4 up to 1, that will be equal to 24, and so on. So, I strongly recommend you to learn up to 8 factorial, like up to 8 factorial. So, let me write over here. 0 factorial is predefined as 1, as I already told you. 1 factorial value will be 1. 2 factorial value would be 2. 3 factorial value should be 6. 4 factorial value should be 24. 5 factorial value should be 120. 6 factorial value should be 720. 7 factorial value should be 5040. 8 factorial value should be 40320. 40320. 9 factorial will be 3 lakh. 62,000. See, this is 3,60,000 when I multiply it with 9. So 320 into 9 will give you 2,880. So that's why it is 3,62,880. But it is strongly recommended to by heart up to 8 factorial. Knowing up to 9 factorial is extraordinary. What is the advantage of this, sir? When you are doing the calculations in the exams, again doing the calculations requirement will not come. You can simply recollect whatever is by hearted, so that will save some time while doing the calculations. So we strongly recommend you to go for learning factorials up to 9. But up to 8 is mandatory, 9 is your choice. So learn up to 9, that is strongly recommended. Next concept, NPR notation. NPR notation. So NPR is nothing but the formula of NPR is this one. So NPR is equal to n factorial by n minus r factorial. N factorial by n minus r factorial. That is the formula for NPR. Now going ahead with, if I go for 10p2 is nothing but start with 10 and write 10 factorial. So let me write in detail first. 10 factorial by 10 minus 2 will be 8. This 10 factorial by 8 factorial on expansion becomes 10 into 9 into 8 factorial by 8 factorial. That is equal to 10 into 9. That is equal to 10 into 9. So 10p2 is 10 into 9. So in short, without you doing all these things in the exam, 10p2 means start with 10, write 2 numbers, close. Similarly, if I want 10p3, let us say, start with 10, write 3 numbers, reducing each by 1. That is enough. 10 into 9 into 8. Similarly, if you have something like this, 5p5. 5p5 is nothing but start with 5, write 5 numbers. So 5 into 4 into 3 into 2 into 1. That gives you the result as what? 5 factorial. Starting with n going up to 1. That represents what? N factorial. N factorial. Right. So from this I can say NPN is always equal to n factorial. Like that I can say. Now when you have something like this, say suppose you have 100 P98. If this is given, they will never give you expanded answer in the exam because this is such a big value. 100p98 means start with 100, write 98 numbers, 100 into 99 into 98 into 97 into 96 into 95 into 94 into like the 98 numbers you have to write. That product will be so big that cannot be given in an option. That's why in the exam, if 100p98 is coming out to be your answer for a particular problem, answer will be given as 100p98 only. It will not be given in simplified form. That they will take care. You need not be worried about that. Keep this in mind. Now coming to the facts related to this one. So as I said, 10p2 is nothing but 10 into 9. Similarly, 10p2 I have written. 15p3 if I want. Start with 15, write 3 numbers. 8p4 means start with 8, write 4 numbers, 8 into 7 into 6 into 5. As I have already said, np0 is 1, np0 is 1, np1 is n. np1 means start with n, write only 1 number, that is n only. So np2 is nothing but start with n, write 2 numbers, so n into n minus 1. Likewise, NPN is equal to what? Start with n, write n numbers. That will become what? N factorial, as I have already explained. Right, dear. And please remember, whenever you are going for defining NPR, R should always be less than or equal to n. R value can never exceed n. R value can never cross n. Keep this in mind. Right, dear. Next concept, NCR notation. NCR notation. So what is this NCR notation here? So NCR notation is NCR is equal to n factorial by r factorial into n minus r factorial. N minus r factorial. That is the formula. Now, if I go for 10C2, let us say 10C2, if I go for 10C2 is nothing but 10 factorial by 2 factorial into 10 minus 2. 10 minus 2 is nothing but 8. That's why that is 10 factorial by 2 factorial into 8 factorial. That can further be written as 10 factorial into 9 into 10 factorial is 10 into 9 into 8 factorial by this is 2 factorial 8 factorial. So why I have stopped at 8 factorial? Because I want to cancel that 8 factorial with this 8 factorial. That gives you what? 10 into 9 by 2 into 1. 10 into 9 by 2 into 1 will give you how much? 45. Similarly, if I want 10C2 in the simplified manner, start with 10, write 2 numbers. By start with 2, go up to 1 at the bottom. 10C3, start with 10, write 3 numbers at the top. 10 into 9 into 8. By start with 3, go up to 1 at the bottom. That will give you 10C3. If I now have something like this, 100C98. 100C98 can simply be written as, there is a shortcut for it. Whenever you are having a value here which is more than half of n, the value of r is more than half of n, then we recommend you to go like this. NCR is equal to NCN minus r. So 100C98 can be written as 100C 100 minus 98. So 100C 100 minus 98. 100 minus 98 is nothing but 2. So that can also be written as 100C2. So 100C98 can also be written as 100C2. Keep this in mind. Now it is easy to handle. 100C2 is nothing but start with 100, write 2 numbers. By start with 2, go up to 1. As simple as that. Now NC0 is nothing but 1. NC0 equal to NCN. Based on this logic, NC0 and NCN will be equal. So NC0 and NCN both will be equal to 1. NC1 is equal to n. Please remember, NC0 and NCN are equal in NCR, whereas NP0 is not equal to NPN. Keep that in mind. NPN is n factorial, whereas NP0 was only 1. Keep this in mind. Right, dear? NC1 is n. NC2 is nothing but start with n, write 2 numbers. N into n minus 1 by 2 into 1 is nothing but 2. NC3 is nothing but n into n minus 1 into n minus 2 by start with 3, go up to 1. So that is 3 into 2 into 1. That will give you 6. Similarly, NCR equal to NCN minus R. So the suggestion for this is, as I told you already, when R is more than half of n, using this relation will simplify our calculation. That's why try to use this relation only when if you feel that R value is more than half of n, then only you try to use that. Otherwise, don't use it. Right, dear? Next, one more relation I want you to remember here is NCR minus 1 plus NCR equal to n plus 1 CR. What do we mean by that? Just check. 10C R minus 1. So 10C 6 plus 10C 7. NCR minus 1 plus NCR equal to n plus 1 CR, meaning that is equal to n plus 1 means 10 plus 1 is 11 CR. So R is nothing but what? 7. So that is equal to 11 C7. To make it more simpler, so here you might find it difficult to calculate that one. So I'll make it simpler like this. I'll take simple numbers. 5 C3 plus 5C4 is equal to n plus 1 is 6C4, n plus 1 CR. If you have a doubt, you can check it now. So here 5C3 is nothing but 10 plus 5C4 is nothing but 5. 6C4 is nothing but 6C2. 6C2 is nothing but 15. Is it working or not? Yes. That's what I am trying to say. Whenever you are having NCR minus 1 plus NCR, that will directly be calculated by using this formula. So it is always equal to NCR minus 1 plus NCR is always equal to what? N plus 1 CR. Remember this also. That relation will help you when you are doing some calculations in the exam. Right, dear? So 100C 98 is nothing but, I can write it as 100C 100 minus 98. So that is equal to 100C2. You are using this relation here because R is more than half of N. That's why. Similarly, 40C 32. 40C 32, this 40 half is 20. So this is more than half of R. That's why I'll write it as NC n minus R. So 40C 40 minus 32, that is equal to 40C8. Calculating 40C8 is simpler than 40C 32. That's why I have used that one, because 32 is more than half of 40. Similarly, 24C3. As this R is less than half of this is 12. This 3 is less than 12. That's why I did not use NCN minus R. So, sorry, NCN minus R, I am directly going for what? NCR value I am directly calculating. So, 24C3 means started with 24, written 3 numbers by, start with the 3, go up to 1 at the bottom. So, here I did not use NCN minus R idea. That's what I have written. So, here 3 is less than 24 by 2. Hence, taking 24C3 itself is better. That's the reason why I did not use it. So, that's why knowing the relation is one part and understanding when to use that is more important. Many people know NCR equal to NCN minus R. The problem with them is they don't know when to use it. So, use it only when R is more than half of N. Then only it is recommended to use that relation. That is the basic thing you should remember. So, NCR equal to NCN minus R, but 100, like when you take NPR, NPR is never equal to NPN minus R. So, only NCR is equal to NCN minus R. NPR is never equal to NPN minus R. Keep this in mind. Now, the next thing that we have to understand for you to solve the problems from this chapter is the concept of fundamental principle of counting. This fundamental principle of counting is something which is the base of thinking for all the concepts you are going to get in permutations and combinations. So, what is fundamental principle of counting? If a work W1 can be performed in m different ways and another work W2 can be performed in n different ways, then the two works simultaneously can be performed in n different ways. So, m n, or I can write it as m into n. They can be performed in m into n different ways. Right. So, for example, I am taking, say suppose a person is willing to go from Hyderabad to Mumbai via Pune. In how many different ways he can go? There are 2 different routes possible from Hyderabad to Pune. From Pune to Mumbai, there are 3 different routes available. In how many different combination of routes he can travel means, so he can travel totally in how many ways? There are 2 ways to go from Hyderabad to Pune. This is task 1. Going from Hyderabad to Pune is task 1. Pune to Mumbai is task 2. So, work W1 can be done in 2 ways. Going from Pune to Mumbai can happen in 3 ways. So, in total, you can travel in how many ways? 6 different ways. So, how, sir? If you want, I'll clarify. A, B. I'm just naming them. C, D, E. In how many different combination of routes you can travel? So, going from Hyderabad to Mumbai means it is a combination of 2 routes. Go from Hyderabad to Pune via route A. After that, you can choose any of these 3 routes. So, after choosing route A from Hyderabad to Pune, he can choose any of the routes from C, D, E. That can happen in 3 different ways. Similarly, if he goes by route B from Hyderabad to Pune, from there he can choose any of the 3 routes from C, D and E. That is C, D. So 2 tasks are there. So for him to go from Hyderabad to Mumbai, 2 things have to happen. One is reaching Pune. Second one is reaching Mumbai. To reach from Hyderabad to Pune, there are 2 different routes available. To reach from Pune to Mumbai, there are 3 different routes available. Effectively, we are having how many different routes? 6 different routes are possible for a person to travel from Hyderabad to Mumbai. Here, task 1 is going from Hyderabad to Pune. Task 2 is going from Pune to Mumbai. This concept, if it is clear, handling the problems from permutations and combinations chapter is never difficult. Now let us go into the examples related to this concept. Example 1. Suppose there are 4 different modes of transport available to travel from Hyderabad to Chennai. Hyderabad to Chennai, there are 4 different modes of transport available. That is, I can go by bus, a car, train or aeroplane. There are 4 different modes of transport available. And 3 different modes of transport from Chennai to Bangalore. From Chennai to Bangalore, there are 3 different modes of transport. They are going either by bus or train or aeroplane. Then how many different modes of transport are available for a person to travel from Hyderabad to Bangalore? So for a person to go from Hyderabad to Bangalore, how many modes of transport are available in total? Now, first, a person has to go from Hyderabad to Chennai. Hyderabad to Chennai, there are 4 different modes of transport available. After reaching Chennai, he has to go to Bangalore. From there, there are 3 different modes of transport available over here. So effectively, a person can go from Hyderabad to Bangalore via Chennai in how many different routes over here? He can go from Hyderabad to Chennai first. That can happen in 4 different ways. Any of the 4 modes of transport he can choose. From there, he can choose any of the 3 modes of transport available. So effectively, how many routes are available or how many modes of transport are available? 12. Hence, your answer has to be 12. That should be option 4. Next, example 2. A man has 3 different colored trousers and 2 different colored shirts. Then in how many ways he can select a pair, a trouser and a shirt? So a person is having 3 different colored trousers with him, 2 different colored shirts with him. In how many different ways he can choose a pair of dress? So dress is nothing but a trouser and a shirt over here. So in total, in how many ways he can choose? So you can choose, there are 2 tasks to be performed. First one is choosing a shirt. Choosing a trouser, then choosing a shirt. A trouser can be chosen in how many different ways? 3 different ways, because there are 3 different colored trousers. Similarly, shirt can be chosen in 2 different ways. So in total, in how many ways he can choose? 6 different ways he can select a pair of dress. So there are 6 different ways possible to select a trouser and a shirt together. Hence, it should be option 1. Next, problem number 1 from the exercise handout. There are 4 routes to travel from city A to city B and 6 routes from city B to city C. How many routes are possible to travel from city A to city C? A person who is willing to travel from city A to city C can travel in how many different ways here? So there are how many routes from A to B? 4 routes are there from A to B. From B to C, how many routes are possible? 6. In total, a person can travel from A to C in how many different ways? 24. Hence, your answer has to be 24. That should be option A. Next, problem number 2. This is more interesting here. Be careful. Right. A, B and C are 3 places such that there are 3 different roads from A to B, 4 different roads from B to C and 3 different roads from A to C directly. In how many different ways can one travel from A to C using these routes? So what mistake people have done? So people did not read properly. They did it this way. This is the trap. What is the trap? They felt A to B, how many roots are there? There are 3 different places where there are 3 roots from A to B. B to C there are 4. A to C there are 3, means they multiplied this. That is giving you how much? 36. But this is absolutely wrong. Because it is not A to B, B to C. If at all it is A to B, B to C, we will multiply this. A to B, B to C. If at all they give C to D, we will multiply like this. But what they have given over here is a bit intelligently they have given. 3 different roots are there from A to B. That is 5. From B to C, there are 4 different roots. B to C, there are 4 different roots. And there are 3 different roots directly from A to C. From A to C directly, there are 3 different roots. So in total, in how many ways he can go? To go from A to C via B, he can go in how many ways? He will reach B, then he will reach C. So A to C via B, he can reach in 12 ways. Directly from A to C, we are having 3 different ways. In total, in how many different ways he can go directly? A to B, B to C, he can go in 3 into 4, 12 ways from A to C via B, plus directly from A to C we are having 3 ways, so plus 3. Hence your answer has to be how much? 15. Hence your answer has to be option C. That's a trap that was given in UPSC CSAT exam. Right, dear? If at all they have given A to B, B to C, C to D, then we would have multiplied 3 into 4 into 3. Then it will be right. But here, correct answer for this problem is what? Option C. Be aware of this type of traps in the competitive examinations. Next, the concept of combinations. So, what is a combination? So, combination is just a selection. That's all. So, out of n distinct objects, similar or dissimilar objects that are available, if you are choosing R objects, out of n similar or dissimilar objects, choosing, just selecting R objects is called as a combination. So, selecting some or all of the number of objects that are available is called as a combination. So, a combination is only a selection. There is no importance to the order or arrangement of things in a combination. So, in combinations, order is not important. Say, suppose you are having 3 people A, B, C. In how many ways you can select 2 means order here is not important. Whether it is A, B or B, A is one and only same. Because I am just choosing 2 people out of 3 people that are available. So, where I take A, B or B, A, it doesn't really matter. Both are only same combination. So, the order is not important. Right, dear? Similarly, AC or CA is one and only same. BC and CB are one and only same. Erase it. So, how many different ways you can choose 2 people out of 3 people? 1, 2, 3. In 3 different ways you can choose. As it is out of 3 choosing just 2 people, you can do it manually. That's not a big deal. But when you have more people, selections will become complicated. So, you cannot do like this manually. We have to be aware of some formulae that we will learn as we move on. So, here, there's a combination of n things taken R at a time can be regarded as a subset with R elements of a set containing n elements. So, whenever you are choosing out of n things, if you are choosing R objects, it is as good as it is subject subsets of R elements out of n elements that are available. This concept of sets, I will talk about it as we move on. For now, you just keep aside that concept of subset for some time. Now, coming to the basic formula related to this. The number of combinations of n dissimilar things taken R at a time. Out of n dissimilar things that are available, taking R at a time is given by the formula NCR. Out of n distinct objects, choosing R objects is NCR. That NCR is equal to n factorial by n minus r factorial into r factorial. This formula we have already learned. So out of n distinct objects that are available, if you are trying to select r distinct objects, so the number of combinations will be NCR. Now, find the number of ways of selecting 7 members from a contingent of 10 soldiers. So there are 10 soldiers available. Out of the 10 soldiers, in how many ways you can select 7 members, they are asking. So out of 10 you have to select 7. Out of 10 you have to select 7. So how can we do that? So there are 10 people available. Out of 10 people you choose any 7 of your choice. That can happen in how many ways? 10C7 ways. Out of 10 you can choose any 7 in 10C7 ways. The 10C7 is nothing but NCR is nothing but NCN minus R. That is equal to, as R is more than half of this, as R is more than half of N, we will use NCN minus R. So that is equal to 10CR, that is equal to 10C, 10 minus 7, that is nothing but 10C3, 10C3. So 10C3 is nothing but, how do we simplify? Start with 10, write 3 numbers in the numerator. By starting with 3, go up to 1 in the denominator. On simplification, that will give you the result as how much? 120. So how did you get it, sir? Let me show you. 3 3s are 9, 2 4s are 12. 3 4s are 12. 12 into 10 will give you how much? 120. Hence your answer has to be 120, and that should be option 3. Next, problem number 3. A 3-member committee has to be formed from a group of 9 people. There are 9 people available. Out of that 9 people, a group of 3 members, a committee of 3 members has to be formed. How many such distinct committees can be formed? So how many people are available over there? This is unconditional selection. Out of 9, you choose any 3. You are free to choose any 3. 9C3. This R is less than half of this. Half of 9 is 4.5. So this is less than 4.5. That's why you calculate it like this only directly. Don't take it as NCN minus R. Not needed. So 9C3 can be written as, start with 9, write 3 numbers at the top. By start with 3, go up to 1 at the bottom. That is giving you how much, dear? 84. 84. Hence your answer has to be 84, and that should be option D. Next, let's have a look at problem number 4. In how many ways can a selection of 5 persons be made out of 4 men, 3 women, 2 boys and a girl? So here they have asked you to select any 5 out of the total. How many people are available? Available are 4 men, 3 women, 2 boys and 1 girl. This is the group that is available. In total, the number of people available are 10 people are available. In total, 10 people are available. Out of the 10 people available, they asked you to select any 5. Any 5. They are not specific about, out of that 5, how many boys should be there, how many girls should be there, how many men should be there. They did not mention. So you choose any 5 out of the 10 available. Hence your answer is, out of 10 you choose 5. This R is exactly half of N. So you directly go for NCR only. So start with 10. Write 5. 10 into 9 into 8 into 7 into 6 by 5 into 4 into 3 into 2 into 1. So here, if you go for cancellation, 5 2s are 10, cancel. 4 2s are 8. 3 2s are 6. That's what I have. Now this is giving you how much? 9 2s are 18. 18 7s are 126. 126 2s are 252. Hence your answer has to be 252. That should be option A. Next, problem number 5. In how many ways a committee of 3 members can be selected from a group of 10 members such that one particular person is always included? Here you have to be very careful. One particular person is always included. So I am giving you a group of 10 people and I am asking you to select 3 people. I am asking you to select 3 people and I said this fellow must be there. This fellow must be there means you are free to select only the remaining 2. So out of the 10 that are available, as one particular person is already included, now you have how many people available for selection? 9. You need to select in total how many people? 3, but out of that one particular person is already included means you have the choice of selecting only 2. Now as a selector, you are free to select only 2 people now because one person is already included. So you are free to select 2 people now out of that remaining 9 people. Hence your answer has to be out of that remaining 9 people, you have to choose 2 people. 9C2. That will give you 9 into 8 by 2 into 1. That will give you 9 into 4. That should be how much? 36. Hence your answer has to be 36 and that should be option C. Next, problem number 6. In a group of 30, there are 15 males and 15 females. There are 30 people out of which 15 are males, 15 are females. In how many ways can a committee of 25 members be formed? So total number of people to be selected are 25. A committee of 25 can be formed such that it always includes 10 particular males and 10 particular females. Which means out of the 30 available, 10 particular males are already included and 10 particular females are also already included. Remove them. Now we have how many people available for selection? Only 10 people are available for selection. So out of 25, already 20 people are included. We need to select 5 more. So we need to select a total of 25. Already 10 particular males and 10 particular females are included means remove the 10 males included, 10 females included. Now we have to select only how many people? 5. I need to select the remaining 5 people from the remaining 10 people. Out of 30 there are 10 people remaining. Out of that 10 you have to choose any 5. Hence your answer has to be what? 10C5. 10C5 is nothing but 10 into 9 into 8 into 7 into 6 by 5 into 4 into 3 into 2 into 1. This gives you, check, 5 2s are 10. Next 4 2s are 8. Next 3 2s are 6. What am I left with? 9 2s are 18. 18 7s are 126. 126 2s are 252. So in how many ways I can select them? In 252 different ways I can select them. Hence your answer has to be option A. Next, problem number 7. In how many ways a cricket team of 11 members be selected from 15 players so that a particular player is included and another particular player is left out? So both the conditions given now. So one of the fellow must be there, one of the fellow must not be there. So now how many people are available for selection? You just Check out that. In total, we are having how many people? 11 people should be selected out of 15. Out of that 15, one fellow is included, one fellow is excluded. Now we have how many people? 13 people. 13 people. Now we have 13 people available for selection. Totally we need to select how many people? 11. Out of the 11 to be selected, one particular person is already included, means you are free to select only how many people now? 10 people. Even though you have to select 11 people, as one person is already there in the team, as one person is already included, you are free to select only 10 more from the remaining 13. Hence that can happen in how many ways? From 13 people you have to choose 10. As R is more than half of N, it should be how much? NCR equal to NCN minus R. That can be written as 13C, 13 minus 10. That should give you, as R is more than half of N, I am using this logic. So that is equal to 13C3. 13C3. 13C3 is nothing but start with 13, write 3 numbers at the top. 13 into 12 into 11 by 3 into 2 into 1. This gives you 3 2s are 6, 6 2s are 12, 13 2s are 26, 26 11s, that will give you how much? 286, 286. Hence your answer has to be option C. Next, problem number 8. In how many ways a committee of 3 members can be selected from a group of 10 members such that one particular person is always excluded? One particular person is always excluded. One particular person is always excluded means totally how many people we need to select? 3. One particular person is excluded means we have to select only 2. So total available are 10. As one particular person is always excluded, keep him aside. Now we have how many people available for selection? Only 9 people are there for selection. Even though 10 people are there, one fellow I cannot touch, so keep him aside. So I have only 9 people to choose from. I need to select how many people over here? 3 people. Is there any person who is already included? No. I just have got a condition that one fellow should never be selected. That means you are free to select any 3, but not out of 10, but out of only that remaining 9, because one fellow can never come. So you are free to select any 3 of them out of 9. Hence your answer has to be 9C3. 9C3 is nothing but 9 into 8 into 7 by 3 into 2 into 1. That gives you how much? We have already seen this calculation. 3 3s are 2 4s are 3 4s are 12, 12 7s are 84. Since your answer has to be 84, that should be option A. This 9C3 calculation we have already seen. If you want, I'll show you once. 9C3. Out of 10 choosing 3 people. Next, out of 9 choosing any 3 people. So out of 9 choosing any 3 people. Unconditional selection was given. Here I have given you 10 and I asked you to select 3. But I said one particular fellow should never be included. So here also answer we are getting it as what? 84. Next concept is finding the number of handshakes. This is more interesting, right? For you to have a handshake, you need 2 people. Between any 2 people, see, a person gives shake hand to another person once means between any 2 people, there will be only one shake hand that is taking place. So for you to have a handshake, 2 people are needed. So finding the number of handshakes means in a group of n persons, if each person shakes hands with every other once, then the total number of handshakes that took place is equal to NC2. That NC2 on simplification is written as what? N into n minus 1 by 2. N into n minus 1 by 2. So why NC2 is because for a shake hand to take place, we need 2 people. Out of a group of n people, if each person is shaking hand with every other person, then we have to count in how many ways you can choose 2 people out of that n people that are available, and that will be NC2. That NC2 on simplification will become what? N into n minus 1 by 2. Now going ahead, 10 people at a party shake hands once with everyone else in the room. How many handshakes took place? So there are 10 people over there. Out of 10, every person is shaking hand with every other once. So the number of shake hands would be, out of 10 you choose any 2. That's why it is n into n minus 1, 10 into 9 by 2 into 1 is what? 10 into 9, n into n minus 1 by 2. That will give you how much, dear? 45. As I can see, the total number of handshakes in the meeting would be what? 45. And that should be option B. Next, in a birthday party, every person shakes hand with every other person. If there was a total of 28 handshakes in the party, how many persons were present in the party? This is reverse. They have given the number of handshakes. They are asking you for the number of people in the party. Going ahead. So how many people are there? You just check. In a birthday party, every person is shaking hand with every other. Number of people, I am assuming it as n. So number of shake hands is n into n minus 1 by 2. N into n minus 1 by 2 is given as how much? 28. Number of handshakes, I know. Number of handshakes formula is this, n into n minus 1 by 2. If n into n minus 1 by 2 is 28, so from that I can get n into n minus 1 is equal to 28 to the how much? 56. Please keep in mind, whenever you come across the product of two consecutive natural numbers, to find that value of n over here, do not solve the equation. I'll tell you the trick here. The shortcut trick I am going to show you. This will help you in handling calculations in other chapters also. So what is the trick, sir? Whenever you have the product of two consecutive natural numbers, to know what is the value of n here, n into n minus 1, we got it as 56. Na? Remember one thing. This 56 lies between which two squares you write? That 56 lies between what? 7 square 49. This is more than 7 square 49. Less than 8 square 64. So this value is between 7 square and 8 square. Now only one thing that you have to understand here is this, in this equation, n is a big value or small value? N is big, n minus 1 is small. So n is bigger value. Between those two values you have got, what is the big value you have between 7 and 8? Big value is 8. So n value should be 8. Sometimes maybe you may get like this, n into n plus 1. So n into n plus 1 if you take, n into n plus 1 is given as, let us say 306. This 306 is lying between which two squares? 17 square 289, 18 square 324. So please remember, this technique you can use only when it is the product of two consecutive natural numbers. Please know the limitation of the shortcut. So in this product, n is a small value or bigger value? N is corresponding to small because n plus 1 is bigger. As n is corresponding to small, that small value between 17 and 18 is what? 17. Hence your answer has to be 17. So whenever you come across the product of two consecutive natural numbers, to find what is the value of n, you follow this shortcut technique. So coming back to this one, so the value of n here will be how much? From this I can say n will be equal to 8. N will be equal to 8 because it is representing n into n minus 1, product of two consecutive natural numbers. As 56 is lying between, as I have already explained on the next slide, 7 square 49, 8 square 64. As n here is representing a bigger value, so n must be equal to what? 8. N must be equal to 8. Hence it should be 8. Or otherwise, no sir, I don't want to do this. You can go with the options also. Once you get this n into n minus 1 equal to 56, put n equal to 8 here, first option. 8 into 8 minus 1 is 7. 8 into 7 is how much? 56. Is it matching? Yes. Hence your answer has to be option A. Next dear, problem number 11. This is more interesting. If every person shakes hands with every other person, the story is different. This I am going to show is different again. Check. There are 10 men and 8 women in a group. If men shake hands with only men and women shake hands with only women, then the number of shake hands that take place is what? Men are shaking hands only with men, women are shaking hands with only women. So here the shake hands between men will take place and shake hands between only women will take place. So the number of shake hands among men is how much? Out of 10 men, you choose any 2 men that will lead to a shake hand. This is the number of shake hands between men. Plus between every 2 women there is a shake hand. Out of 8 you choose any 2, that is 8C2. 10C2 is nothing but n into n minus 1 by 2. So that will give you 10C2. That is nothing but n into n minus 1 by 2. Plus 8C2 is nothing but 8 into 7 by 2. This gives you how much? Just cancel it with 2. 2 5s are. So 9 5s are how much? 45. 7 4s are how much? 28. 45 plus 28 will give you how much? 73. So the total number of handshakes that are going to take place are how many? 73. These are the shake hands among men. These are the shake hands among women. Total number of shake hands are this plus this. Totally 73. Problem number 12. Same story. There are 10 men and 8 women in a group. If men shake hands only with women and women shake hands only with men. So this is opposite. So men are shaking only hands with women. Women are shaking hands only with men. Then how many shake hands will take place? Now for you to have a handshake, it is not NC2 now. You need 2 people, but 1 from each group. So out of 10 men that are available, out of 8 women that are available, for a shake hand to happen, you need 1 man and you need 1 woman. So choose 1 man and choose 1 woman that leads to a shake hand. So out of 10 men available, choose 1 man. In how many ways? 10C1. You have chosen man. So after choosing a man, you have to choose a woman for the shake hand to take place. Out of 8 women that are available, you choose 1 woman. So the total number of shake hands over here are how many dear? 10 into 8. That's why blindly by hearting n into n minus 1 by 2 will not help you in getting the answers. Know the logic. Why NC2? Why NC2? That is mandatory. So here I need 2 people, but 1 from each group. 1 man I need, 1 woman I need for a shake hand to happen. So that's why it is 10C1 into 8C1. That is 10 into 8 will give you how much dear? 80. Hence your answer has to be 80 and that should be option C. Next, problem number 13. 6 married couples attend a dinner party. At the start of the evening, everyone shakes hands with every other person exactly once. Every person shakes hands with every other person exactly once. Except that no person shakes hands with their own spouse. How many handshakes take place? This is more interesting. How many couples are there? 6 married couples are there. 6 married couples are there. 6 married couples are there. And everyone shakes hands with every other person exactly once, except that no person shakes hands with their own spouse. Now going ahead with, say suppose you look at it this way. 6 people are there, every person shake hands with every other person, let us say. Then the total number of shake hands will be how much? If every person is shaking hands with every other person, 6 married couples are there. Please be careful. 6 married couples are there. 6 married couples are there means how many people are there? 12 people are there. Out of 12 people, every person shake hands with every other once. So the total number of handshakes will be how much? 12C2. 12C2. This is the first thing. 12C2. Out of that, between any couple, there is no shake hands. So how many couples are there? 6 couples are there, means 6 shake hands you should not count. Those shake hands, out of this, like a couple may be shaking hand with each other. Wife and husband may be shaking hand with each other in this particular combination. But I should not count those shake hands where a man is shaking hand with his wife. So there are 6 couples, means there are 6 such shake hands where a wife is shaking hands with a husband. That 6 shake hands I have to remove. 12C2 is nothing but n into n minus 1 by 2. So that is 12 into 11 by 2 minus 6. That is equal to 66 minus 6. 66 minus 6 will give you how much, dear? 60. Hence your answer has to be 60. Like this, by giving shake hands, they can give you conditions. That's where it will become difficult. So be careful. So don't be in a hurry to just answer it blindly like NC2. Yes, it is NC2. If every person shakes hands with every other person, that is NC2, no doubt. Out of that, they have added a condition saying that what? No man is shaking hand with his wife. That means there are 6 married couples, means there are 6 such shake hands which should not be counted. That I have removed from this. Right here. Next, problem number 14. There are 6 persons arranged in a row. Another person has to shake hands with 3 of them so that he should not shake hands with 2 consecutive persons. In how many distinct possible combinations can the handshakes take place? This will be found in 2 different approaches. I'll show you the logical approach, I'll show you the formula approach also. Now let's go for the formula approach here for this type of problem. Whenever you are having n distinct objects, out of that, if you want to select R objects, out of n distinct objects, you want to select R objects such that no 2 are consecutive. So here there are how many people here? 6 people are there. Out of 6 people, you have to choose how many people? 3 people. Such that no 2 people are consecutive. So out of n objects, you can choose R objects such that no 2 are consecutive in how many ways? N minus R plus 1 CR ways. Out of n objects, you can choose R objects such that no 2 are consecutive. Can happen in these many ways. Hence, it will be n minus R plus 1 CR. So CR. So here n is 6. So out of 6 you have to choose 3 such that no 2 are consecutive. So 6 minus 3 plus 1 C3. This gives you 3 plus 1 4. So that will give you 4C3. 4C3 is nothing but what? 4. This is one way of looking at it. Out of n objects, R objects can be chosen such that no 2 objects are consecutive. No 2 are consecutive in n minus R plus 1 CR ways. Another way of looking at it would be go by analysis. 1, 2, 3, 4, 5, 6. Right? Combinations A, B, C, D, E, F, I am saying. What are the combinations you can choose? A, if you choose A, you cannot choose B. Then you choose C, then you cannot choose D, you choose E. Or A, C, you keep it as it is. A, C, you keep it as it is. Then choose F. Then choose F. Or instead of A, you choosing A, start with A. Instead of C, you choose D. A, D, F. A, D, F. That is the next one. A, D, F. Now if you go for B, if you start with B, you cannot choose C. D, F. B, D, F. Can you start with C? No. If you choose C, then you have to choose E. After E, whom will you choose? You cannot choose any. So C, E, then you have to choose A. That is nothing but A, C, E only. Again. That's the reason why you cannot have any other combination except these 4. So whenever you come across a situation where the number of ways of choosing R objects, number of ways of choosing number of ways of choosing R objects out of n distinct objects. Choosing R objects out of n distinct objects. R objects out of n distinct objects. Such that no two are side by side, or such that no two are consecutive. Such that no two are consecutive. No two are consecutive is given by the formula. Is given by the formula n minus r plus 1 CR. That formula I have written here. I am writing the explanation over here. So answer for the problem is what? 4. That should be option B. Next, problem number 15. 5 teams have to compete in a league with every team playing every other team exactly once before going to the next round. How many matches will have to be held to complete the league round of matches? So how many teams are there? 5 teams are there. Every team plays with every other team exactly once. So that means for a match to happen, you should have 2 teams. Na? So out of 5 teams that are available, you choose any 2 teams. Between them, there will be 1 match. That's why the total number of matches is nothing but 5C2. 5C2 is nothing but 5 into 4 by 2. Like shake hands. For a shake hand, you need 2 people. For a match, you need 2 teams. This gives you how much, dear? 10. Hence, the total number of matches that have happened are how many? 10. Hence, it should be option B. Next, problem number 16. 5 teams have to compete in a league with every team playing every other team exactly once before going to the next round. How many matches will have to be held to complete the league round of matches? So here, same problem I think that is repeated here. So 5 teams have to compete with every other. 20, 10, same problem here. This is a repetition problem, right? This is repetition. Same problem repeated. Next, problem number 17. In a tennis singles tournament, a total of 66 matches were played. Every 2 players played 1 match with each other. Find the number of players who participated in the championship. So it is a knockout tennis tournament. Every person is playing with every other once, means it is n, like NC2. Out of n people, every person plays a match against every other person, means NC2. Between any 2 people, 1 match will happen. That NC2 is given as 66, and we know that NC2 is nothing but n into n minus 1 by 2. So n into n minus 1 by 2 is nothing but 66. From this I can say that n into n minus 1 is equal to 66 to the 132. 66 to the 132. So you can go by options from here, or you can also go by the shortcut technique I have given. Check, this is lying between which 2 square? That is lying between 11 square 121 and 12 square 144. So this is lying between 11 square and 12 square. Hence, as they are asking you for n over here, n is representing large or small. Here n is representing large number. Hence your answer has to be what? 12. Hence I can say that n should be how much? 12. Hence it should be option B. Next, problem number 18. This is more interesting. In a tournament, there are 43 junior level and 51 senior level participants. Each pair of juniors play 1 match. Each pair of seniors play 1 match. There is no junior versus senior match. So between juniors there are matches, between seniors there are matches, but between junior and senior there is no match. Next, the number of girl versus girl matches in junior level is 153. while the number of boy versus boy matches in senior level is 276. The number of matches a boy plays against a girl is the total number of matches where a boy plays against a girl is what? This is the problem that was asked in CAT exam. Now, how do we handle this? We know that 43 junior level participants are there, 51 senior level participants are there. That is what is given. Further, they give the number of girl versus girl matches in junior level is 153. The number of girl versus girl matches in junior level. So, suppose in junior level the number of girls are X. Let us say, if the number of girls are X in junior level, the remaining should be boys. Boys should be Y. Right? So, in junior level, I am taking the number of girls as X. Junior level, I am assuming girls equal to X. If the number of girls are X, the number of matches between a girl and a girl would be n into n minus 1 by 2. So, in place of n, I have X. That gives you X into X minus 1 by 2. Is equal to 153. From this I can say X into X minus 1 is equal to 306. From this I can say that this 306 is lying between which two squares? 17 square and 18 square. Out of this, X is representing a big number or small number. Obviously, X minus 1 is small, X is big. So, that X must be taken as what? The bigger value. That is 18. It is now understood that in junior, girls are how many? 18. Girls are 18. Girls are 18 means boys must be how much? So, in junior, boys in junior is equal to how many, dear? Total boys and girls together in junior level is 43. As girls are 18, boys have to be how much? So, here I can say that the number of boys plus girls in junior is equal to how much? 43. From this I can say that boys in junior is equal to how much? 25. Boys in junior is equal to 25. Right? Next, while the number of boy versus boy matches in senior level is 276. In senior level, boy versus boy 276 matches are there. In senior level, let's assume the number of boys as Y. Boy versus boy matches means n into n minus 1 by 2. Y into y minus 1 by 2 is equal to 276. From this I can say y into y minus 1 is equal to how much? That is coming out to be 552. Again, this is lying between which two squares? 23 square 529, 24 square 576. So here y is representing again large number. So out of these two, large number is what? 24. So y should be 24. The number of boys in senior level is 24. Now the question is how much? The question over here is, while the number of senior matches, okay. The number of matches a boy plays against a girl is what? The number of matches where a boy plays against a girl is what? So the number of matches where a boy plays against a girl would be, okay. Now check. In junior level, boy versus girl matches will be how much? Number of boys are how many? Number of boys in junior level are 25, girls are 18. So this is 25 boys are there. Out of 25 boys that are available, Out of 25 boys that are available, you choose one. And out of 18 girls available, you choose one. That will give you how much, dear? 25 into 18. That is giving you how much? 25 into 18 will give you 450. 450. That is the number of matches between a boy and a girl in junior level. In senior level, we know that the number of boys are how many? The number of boys in senior level are how many? 24. If 24 boys are there in senior level, girls must be how much? Girls must be, boys are 24, total is 51, so girls must be 27. Girls must be 27. This is 27 C1. So here, as we know, boys are 24, so in senior level, girls must be how much? So 24 plus girls in senior level must be how much, dear? 51. From this, I can say that girls are equal to how much? 27. So girls in senior level are 27. So number of matches between a boy and a girl in senior level would be 24 boys are there, choose one. 27 girls are there, choose one. That will give you how much? So this gives you how much, dear? 24 into 27 is what I am looking for. So 24 20 is 480. 24 7s are 168. 480 plus 168 will give you how much? 648. 648. So what is the total number of matches where a boy is playing against a girl? So in junior level, I have 450 boy versus girl matches. In senior level, I am having 648 boy versus girl matches. So here they have clearly given there is no match between a junior and senior. So please keep that condition in mind. So the total number of matches that have happened over here are how much? Just add both. That is adding up to how much, dear? 1098. So the total number of matches where a boy is playing against a girl is 1098. Hence your answer has to be option C. So in advanced exams like CAT or management entrance exams, the questions will be like this only. They won't be direct like NC2 equal to no. Those questions also will come in different exams. When you go for advanced exams, you should have this much of analytical skill with you. Keep this in mind. Chalo, let's go ahead with problem number 19, 19th problem. 10 teams participate in a tournament. Every team plays each of the other teams twice. Not once, it is playing twice. The total number of matches to be played is what? So if every team is playing with every other team once, the number of matches played are NC2. This is the number of matches played where every team is playing with every other team once. But here they are saying every team is playing with every other team twice, means the total number of matches will be how much? 2 into NC2. Now 2 into 10C2. That will give you how much, dear? 2 into 10C2 is 10 into 9 by 2 into 1. That is giving you how much? 2 cancel. So that is giving you how much? 10 into 9. That should give you how much? 90. Hence your answer has to be option D. Next concept. Finding the number of diagonals in any polygon with n sides. The number of diagonals that can be found by joining the vertices of a polygon of n sides is nc2 minus n. That nc2 minus n, when you expand and simplify, you will get this formula n into n minus 3 by 2. nc2 is nothing but n into n minus 1 by 2. So nc2 is nothing but, as we know, n into n minus 1 by 2. Minus n. When you do this, it will give you n square minus n minus 2n by 2. That is equal to n square minus 3n by 2. If you take n as common, that will give you n into n minus 3 by 2. Like that, the formula has come. This formula has come in that manner. But why should I take nc2 minus n? Please remember, whenever you are trying to form a diagonal, you need to join two vertices. So joining of two vertices will always give you a diagonal. So, but if you are taking two vertices which are adjacent to each other, that will not form any diagonal. That will just be a side. Let me try to explain that with a simple example over here. I'll take into consideration something like a quadrilateral, and I'll try to explain with that. So, if this is a quadrilateral, it is having four sides, means it has four vertices. Vertex is nothing but the meeting point of sides is the vertex. Four sides are there, means four vertices are there. So, if there are n sides in a polygon, that polygon will have n vertices in that. N vertices. N sides means n vertices. So, joining of any two vertices will lead to a diagonal, I am saying. So, NC2, joining of any two vertices will lead to a diagonal. There are four vertices. Joining of any two vertices will lead to a diagonal. Let me say 1, 2. This is 3, this is 4, this is 5, this is 6. So, as there are four sides, the number of diagonals I am going to get will be 4C2. That 4C2 on simplification will give you 6. In that 6, what are included? 1, 2. I have also included the sides into diagonals. But sides are not diagonals. So, whatever I have counted over here, sides are also counted into diagonals. As there are n sides, that n sides must be removed from the diagonal count. So, from 4C2 remove 4, that will give you the actual number of diagonals in it. So, I can say that the number of diagonals in a quadrilateral is what? 2. This is the reason why if a polygon is having n sides, it will have n vertices, NC2, n vertices. So, number of diagonals will be NC2. From that, you just have to remove the sides, that will give you the actual number of diagonals in it. So, that is, let me rewrite this. So, if there are n vertices, like n sides, it will have n vertices. Choosing any two vertices is leading to a diagonal. But in the process, I will be counting the sides also into diagonal. So, I just have to remove n from that. On simplifying that, you will get this one, that is n into n minus 3 by 2. Right, dear? Now, let's go ahead with the problem. Problem number 20. How many diagonals can be drawn by joining the vertices of an octagon? Octagon will have 8 sides. As octagon is having 8 sides in it, octagon means the number of sides will be 8. Octagon. As the number of sides are 8, number of diagonals will be equal to n into n minus 3 by 2. So, number of diagonals is equal to n into n minus 3 by 2. 8 into 5 by 2. That will give you how much, dear? 20. Since the number of diagonals in a octagon would be how much? 20. Next, problem number 21. If the number of diagonals of a regular polygon, if the number of diagonals in a regular n-sided polygon is 35, if the number of diagonals is 35 in a polygon is 35, then the value of n is what? So, it is clearly given. The number of diagonals value they have given. Number of sides they are asking you for. So, if the polygon is having n sides, number of diagonals is given by this formula. This value is given as how much? 35. N into n minus 3. 35 twos, it will be how much? 70. 35 twos are 70. Now, please be careful. Don't check this is lying between which two squares, because I told you, you have to follow that method only when it is the product of two consecutive natural numbers. N and n minus 3 are not consecutive natural numbers. So, you should not follow the technique. You should go by options only here. So, going by the options, if you go by the options, option A if you take, if you put n equal to 11, 11 into 8 is equal to how much? 88. but I need 70, not working. Second option, if you take n equal to 10, n minus 3 will be 7. 10 into 7 will give you how much? 70. So the number of diagonals are 70 when the number of sides are 10. Hence your answer has to be option B, that should be 10. Next, problem number 22. If the number of diagonals of a polygon is 5 times the number of sides of that polygon is. So here they are giving you the relationship between the diagonals and the sides. The number of diagonals of a polygon is 5 times the number of sides. So the number of diagonals is n into n minus 3 by 2. This number of diagonals is equal to 5 times the number of sides, that is equal to 5 into n. Then find n. N gets cancelled. This gives you n minus 3 is equal to 5 2s are 10. From this I can say n is equal to how much? 10 plus 3. That should give you how much? 13. Hence your answer has to be 13, and that should be option A. Next, problem number 23. In which regular polygon is the number of diagonals equal to 2.5 times the number of sides? So number of diagonals must be equal to 2.5 times the number of sides. That's what they are saying. So number of diagonals is given by the formula n into n minus 3 by 2. That is equal to 2.5 times the number of sides. They said 2.5 times means 2.5. 2.5 times the number of sides. Now go for cancelling the values here. N gets cancelled. From this I can say n minus 3 is equal to 2.5 into 2 is 5. From this I can say n is equal to 5 plus 3. That should be how much? 8. Hence your answer has to be 8. 8 means that polygon will have how many? That polygon is called as what? Octagon. Hence your answer has to be option D. Next concept, counting the number of straight lines and number of triangles. So there are m points in a plane of which no three are collinear, So those points are called as collinear, which are there on the same straight line. So there are n points in a plane of which no three are collinear. Then the number of straight lines. So the number of straight lines that can be formed by joining those points is the number of straight lines that can be formed. Is equal to, so how many points are there? M points. For you to form a straight line, you need 2 points. Joining any 2 points will lead to a straight line. That's why you just have to count in how many ways you can choose 2 points out of the m points that are given over there. That's why your answer should be MC2. So the number of triangles that can be formed is given by the formula MC3. So MC3. For you to form a triangle, you need 3 non-collinear points. Non-collinear points means the 3 points should not be on the same straight line. Such points, if you have 3, with the help of 3 points, you can form one triangle. That's why the number of triangles is given by the formula MC3. Now, going ahead. If there are m points in a plane of which p points are collinear, so there are m points on a plane, totally m points are there, out of which there are p points which are collinear. There are m points out of which p are collinear. Then the number of straight lines that can be formed is MC2 minus PC2. From MC2, you remove those straight lines that were formed by using the lines which are on the same straight line. So from P collinear points, the number of straight lines you have counted, you remove, that is minus PC2. When you are removing that, you are removing that one line that can be found by joining all the collinear points. See, these are collinear points. So the number of like straight lines I am counting with the help of these 4 points is 4C2. 4C2 is nothing but 6. We count 6 straight lines with the help of these 4 points, but you can only see one line over there. You can count it like this: 1, 2, 3, 4, 5. This is 6. Even though I am counting 6 there, you can only see one straight line. That's why all those straight lines that you are forming with the help of collinear points you remove. But with the help of collinear points, there is a scope of forming one straight line. That's why you add 1 to that. Plus 1 you add. That's it. Similarly, the number of triangles that can be formed is given by the formula. So out of m points that are there, the number of triangles that you can form are MC3. Out of that m points, there are p points which are collinear. So the triangles you have counted with the help of collinear points you remove. So that's why minus, remove all those triangles you have counted with the help of collinear points. So MC3 minus PC3 will give you the number of triangles in that. Right, dear? Chalo. Question number 24. 10 points are selected on a plane such that no 3 of them are collinear. 10 points are selected such that no 3 of them are collinear. How many different straight lines can be found by joining these points? How many different straight lines can be formed? So, okay. How many points are there? 10 points are there. Is the number of straight lines, it will be how much? No 3 of them are collinear. So here m is equal to 10. So the number of straight lines, if you want, number of straight lines is equal to MC2. So straight away that will be 10C2. So number of straight lines that can be formed is equal to MC2. That is nothing but 10C2. 10C2 is nothing but 10 into 9 by 2 into 1. That gives you how much, dear? 45. So number of straight lines are 45. Hence it should be option B. Next, let's have a look at problem number 25. There are 12 points in a plane of which 5 are collinear. What is the number of straight lines that can be formed by joining them? Okay, here m is given as 12 and p is given as 5. M is given as 12 and p is given as 5. So the number of straight lines, if you want, so number of straight lines will be equal to number of straight lines is equal to MC2 minus PC2 plus 1. 12C2 is 66, 12 into 11 by 2 into 1. 5C2 is 5 into 4 by 2 into 1, that is 10 plus 1. That should give you how much, dear? 57. Hence your answer has to be option C. Next, problem number 26. 10 points are selected on a plane such that no 3 of them are collinear. Then how many different triangles can be found by joining these points? So the number of triangles is equal to m is given as 10. So if you want the number of triangles, so number of triangles is equal to number of triangles. Number of triangles is equal to 10C3. 10C3 is nothing but 10 into 9 into 8 by 3 into 2 into 1. On simplification, that gives you how much? 120. 3 3s are 9, 2 4s are 8. So 3 4s are 12. 12 into 10 is 120. I am directly doing that. Means your answer has to be 120, and that should be option A. Next, problem number 27. There are 12 points in a plane of which 5 are collinear. Then what is the number of straight lines that can be formed by joining them? Same story. Here M is given as 12. Out of the 12, 5 are collinear. So P is given as 5. They are asking you for the number of triangles. So number of triangles is equal to MC3 minus PC3. MC3 is nothing but 12C3. 12C3 is nothing but 12 into 11 into 10 by 3 into 2 into 1. That will give you how much? 200 and let me write it in detail. 12 into 11 into 10 by 3 into 2 into 1 minus 5C3 is nothing but 5C2. So 5C3 is nothing but start with 5, write 3 numbers by 3 into 2 into 1 you take here. On simplification, 3 2s are 6, 6 2s are 12, 11 2s are 22, 22 10s are 220 minus 3 3 cancel 2 2, 5 2s it will be 10. 220 minus 10 will give you how much dear? 210. Hence your answer has to be 210 and that should be option D. Next, problem number 28. There are 8 equidistant points on a circle. How many right-angled triangles can be drawn using these points as vertices and taking the diameter as one of the side of the triangle? So here there are 8 points on a circle which are equidistant from each other. So by joining them, how many triangles can be formed? They are asking you for. How many triangles they can form? They are asking you for. And you just have to ensure that you are taking diameter as one of the side. And they are asking you for the number of right angle triangles. Don't forget that. And they also have mentioned you have to take diameter as one of the side of the triangle. To solve this one, I'll give you 2 approaches. One, we'll go by logical approach. Then I'll go by giving a formula as well. So as they said, there are 8 equidistant points on a circle. If there are 8 equidistant points on a circle, now they're asking you to find the number of right-angled triangles. They're asking. So number of right-angled triangles. Please be careful. It is not the number of triangles. They're asking you specifically for number of right-angled triangles. Now going ahead. If you take the circle into consideration, as they are saying 8 equidistant points, 1, 2, let me use a different color here, 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 equidistant points. Remember, right angle triangle means diameter should be one of the side, then only you can get a right angled triangle on a circle. So here, if you take this as the diameter, with the help of this, after removing these 2 points, so with the help of 2 points you can form one diameter. After forming the diameter, with the help of any point you can form a right angle triangle. By taking this as one of the side, if you join this, that will become a right angle triangle. Because the angle made in a half circle is always right angle. That is the theorem we have learned in geometry. So here, this is a right angle triangle. By keeping this as one of the side, by joining this point, still we will get a right angle triangle. By joining this also we will get a right angle triangle. Similarly, by joining this point with this also gives us a right angle triangle. Joining this with this also gives us a right angle triangle. Joining these also will give a right angle triangle. So like that we can get how many right angle triangles with the help of the diameter. So now first thing you have to understand is, if there is one diameter, keeping that diameter aside means you are keeping aside those 2 points, you can choose the remaining points. So how many points will be available? N minus 2 points are available. So if there are n points, if you are choosing 2 points for the diameter, you still have n minus 2 points. So with every diameter, you will get n minus 2 triangles, n minus 2 right angled triangles. With every diameter, you will get n minus 2 right angled triangles. Like that, how many diameters you can form? That is another thing. So how many diameters you can form? Now, as you are having, for you to form a diameter, you need 2 points. So 2 points if you are joining, 2 points if you are joining, 2 opposite points I can say. Any 2 opposite points if you join, that will become a diameter. So as there are 8 points over here, you will be having how many pairs of opposite points? 4 pairs of opposite points. So if there are n points which are equidistant on a circle, the number of diameters you can form are n by 2. Because every pair of opposite points will become a diameter. After choosing that diameter, for every diameter, you will be having how many triangles that you can form, keeping aside those 2 points. With the help of the remaining points, you can form one right angle triangle each. That's why for every diameter you are getting, you can form n minus 2 triangles. The total number of triangles you can form will become this one, n minus 2 into n minus 2, n by 2 into n minus 2. N here is nothing but how much? 8. 8 points are there. So how many diameters will come? 4 diameters will come. Because joining any pair of opposite points will become a diameter. For every diameter, how many triangles you can form? N minus 2. Hence it will give you, n is 8. So n minus 2 means 8 minus 2. This gives you how much? Cancel. That will give you 4 into 6. So the total number of right angle triangles that we can form are how many? 24. So I repeat, if you are taking one pair as diameter, after taking the diameter, keeping aside these 2 points, by joining this diameter with any other point will give a right angled triangle. So for every diameter, you will get n minus 2 triangles. Because 8 points are there, now keeping aside these 2 points, you are getting how many right angle triangles here? 6. Like that, for every diameter, you will get 6 triangles. How many diameters are going to come? As there are 8 points, every pair of opposite points will give you a diameter. So number of diameters will be n by 2. So total number of right angle triangles you can form will be what? For every diameter, n minus 2 triangles will come. For total number of diameters in this structure are how many? N by 2. So n by 2 into n minus 2 will be the total number of right angle triangles that you can form in this type of scenario. Hence your answer has to be 24. That should be option A. So please be careful. Having the basics is very much important. If your basics are not clear, solving this type of problems is not easy. Right, dear? Chalo, let's go ahead with the next concept. Finding the number of parallelograms. Finding the number of parallelograms. So if a set of m parallel lines intersect another set of n parallel lines, not parallel to the lines in the first set, then the number of parallelograms we can form is mc2 into nc2. Meaning, if there are some parallel lines like this, 1, 2, 3, and if those 3 lines are intersecting another parallel lines like this, 1, 2, 3, 4, 5, 6, 7. So if there are m parallel lines, m is equal to 3, intersecting with n parallel lines, that is 7. Total number of parallelograms. For you to form a parallelogram, you need 2 horizontal lines, you need 2 vertical lines, will lead to a parallelogram. So 2 horizontal lines combined with 2 vertical lines will form a parallelogram. So to form a parallelogram, you need to choose 2 horizontal lines, you need to choose 2 vertical lines. Now going ahead with now. So out of these 3 horizontal lines you are having, you can choose 2 in how many ways? 3c2 ways, 3c2. Into, out of these 7 vertical lines, you can choose any 2 vertical lines in how many ways? 7 are there. Out of 7 you choose any 2, 7c2. So 3c2 is nothing but 3. 7c2 is nothing but 21. 7 into 6 by 2 into 1. So that will give you 3 into 21. That is giving you how much, dear? 63. Hence the total number of parallelograms in this structure are how many? 63. Now let's have a look at a previous exam problem. Screen CSAT. Chalo. The number of parallelograms that can be formed from a set of 4 parallel lines intersecting another set of 4 parallel lines. There are 4 parallel lines intersecting another 4 parallel lines. How many parallelograms you can form? M is given as 4, N is also given as 4. The total number of parallelograms are MC2 into NC2. 4C2 is nothing but 6, 4 into 3 by 2. Again it is 6. So 6 into 6 is giving you how much? 36. Hence the total number of parallelograms we can form are how many? 36. Hence it should be option D. Next problem 30. A set of 4 parallel lines intersect with another set of 5 parallel lines. How many parallelograms are formed? A set of 4 parallel lines are intersecting with another set of 5 parallel lines. How many parallelograms can be formed? Okay, same formula. A set of 4 parallel lines, M equal to 4, intersect with another set of 5 parallel lines, N equal to 5. Your answer is MC2 into NC2, NC2. 4C2 is nothing but 6, 5C2 is nothing but 10. So total number of parallelograms are how many? 6 into 10. That should be how much? 60. Hence it should be option C. Next problem number 31. There are 4 horizontal lines and 4 vertical lines parallel and equidistant to one another on a chessboard, on a board. What is the maximum number of rectangles and squares that can be formed? Maximum number of rectangles and squares. So rectangles and squares both are same. See, every square is a rectangle. Every square is a rectangle. So in figure counting you might have already learned this one. So I am going with this concept only. So for you to form a rectangle is nothing but like a parallelogram. Rectangle is also a parallelogram. So number of rectangles that you can form over here are how many? M is equal to 4. N is also equal to what? 4. Your answer will be 4C2 into 4C2. So parallelogram is like rectangle is also a type of parallelogram. Keep this in mind. 1, 2, 3, 4. 1, 2, 3, 4. Right, dear? So that is 4. This is 4. So 4 horizontal lines, 4 vertical lines. So how many rectangles and squares they are saying? Rectangle and square means every square is a rectangle. So whenever you count the square, that square is counted in rectangle automatically. So when they are asking you for rectangles and squares, there is nothing but they are asking you for rectangles. A rectangle is as good as parallelogram, because for you to form a rectangle, you need 2 horizontal lines, 2 vertical lines only. You choose any 2 horizontal lines with any 2 vertical lines. So 4 horizontal lines are there. Out of that you choose any 2. 4 vertical lines are there. Out of that you choose any 2. 4C2 is nothing but 6. Again 4C2 is nothing but 6. So 6 into 6 is becoming how much? 36. Hence your answer has to be what? 36. So don't count squares separately, because when you are counting rectangles, that rectangles include squares also into it. Hence your answer has to be what? 36 only. Next concept, this is more interesting one. The number of ways of selecting any number of objects from a set of n dissimilar objects is 2 power n. Any number of objects. Any number of objects means anything from 0 to n. Out of n objects, choosing 0 objects can happen in how many ways? NC0. Out of n you can choose 0 objects in NC0 ways. Out of n objects you can choose 1 object in NC1 ways. 2 objects in NC2 ways, 3 objects in NC3 ways, and so on. N objects in NCn ways. That is always equal to 2 to the power of n. 2 to the power of n. So if you have 4 objects, let us say 4C0 plus 4C1 plus 4C2 plus 4C3 plus 4C4 you will get. That will be equal to 2 to the power of 4. So 2 power 4 is what? 16. If you have a doubt, check. 4C0 is 1. 4C1 is 4. 4C2 is 6. 4C3 is 4. 4C4 is 1. That is adding up to how much, dear? This is 6 plus 5, 11. 11 plus 5, 16. Is it working or not? That's all. So out of n objects, you can choose 1 objects in these many ways, or 0 objects in these many ways, 1 objects in these many ways, 2 objects in these many ways, like that all n objects in these many ways. The total will always add up to 2 power n. That's a direct formula. Now going ahead with the number of ways of selecting 1 or more objects. When they say 1 or more, any number means it is 2 power n. When they say 1 or more, means you are only considering selecting either 1 or more. So NC1 plus NC2 plus NC3 plus NC4 plus dash 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 plus NCN is equal to 2 power n, provided I am having NC0 here. As I don't have NC0 there, so that I can write it as 2 power n minus NC0. That is nothing but 2 power n minus NC0 is nothing but what? 1. Hence your answer has to be 2 power n minus 1. Be careful, some people are writing it as 2 power n minus 1. That is wrong. Which is right? 2 power n minus 1. Minus 1 at the bottom. Right here, keep this in mind. Let's have a look at the problem. That is problem number 32. A man has 5 friends. In how many ways can he invite at least one of his friends for a dinner? At least one of his friends for a dinner means 1 or more you are selecting. That will be 2 power n minus 1. N here is 5. So that is 2 power 5 minus 1. 2 power 5 is 32. 32 minus 1 will give you how much? 31. 31. Meaning, he can invite out of 5 friends, he can invite 1 friend at a time, or 2 friends at a time, or 3 friends at a time, or 4 friends at a time, or all the 5 friends at a time. The total number of ways in which he can invite at least one of his friends for the dinner is what? 2 power 5 minus 1. That will be 31. Hence your answer has to be option B. Next, problem number 33. A man has 10 colleagues whom he wants to invite for lunch. The number of ways in which he can invite at least 2 of them. He can invite at least 2 of them. Which means out of 10 people, inviting at least 2 can happen in how many ways? It is like this. Out of 10, you choose either 2 or 3 or 4 and so on to 10C10. So if at all I was having something like this, 10C0 plus 10C1 here, then it would have been 2 power 10. So what is missing from the 2 power n from 2 power 10? What is missing here? 10C0 is missing. 10C0 is missing. 10C1 is also missing. 2 power 10 is 1024. Minus 10C0 is 1. 10C1 is 10. This is 10C1, dear. That will give you how much, dear? 1013. So out of the 10 people, he can invite at least 2 of the friends for the dinner. In total, in how many ways? 1013 ways. Next, let's have a look at problem number 34. Rahul is having 6 friends. In how many ways can he invite 5 or more friends for dinner? 5 or more friends for dinner. So Rahul is having 6 friends. He has to invite 5 or more. 5 or more means he may be inviting 5 friends or 6 friends. So it will be 5 friends. It is easy to do directly like this, inviting 5 friends or inviting 6 friends. Out of 6 friends, greater than or equal to 5 is what I am looking for. He can invite either 5 friends or 6 friends. Out of 6 friends, he can invite 5 in how many ways? 65 ways. He can invite all 6 friends in how many ways? 66 ways. That will give you how much? 65 is nothing but 6 only. Plus 66 is nothing but 1. That will give you 6 plus 1 as how much? 7. Hence your answer has to be 7. That should be option C. Here be careful what people did. Sir, why are you not going like this? Can't we do like this? 2 power 6. Total is what? 2 power 6. 6C0, 6C1, 6C2 like that if you go. So that is 2 power 6 minus what is missing from 2 power 6? 6C0, 6C1, 6C2, 6C3, 6C4. Don't you think this is ridiculous over here? So strategically it is right. I mean, technically this is right. Strategically we don't recommend it because it is easy to calculate this than this one. So that's why I directly went ahead with this method instead of I going for that other method. So have that logic in mind, right? Problem number 35. A student must select at least 4 elective subjects out of 6 available options. Out of 6 options that are available, he has to select at least 4. In how many ways can the student make this selection? So out of 6, he has to choose at least 4 electives. At least 4 electives. So the number of electives should be greater than or equal to 4. That means he can choose 4 elective subjects or 5 electives or 6 electives. Out of 6, he can choose 4 electives in 64 ways. 5 electives in 65 ways. 6 electives in 66 ways. 64 is nothing but 6C2. 6C2 is nothing but 15. You can calculate here directly. 64, as this is more than half of this, you directly go for what? NCN minus R. So 64 can also be written as 6C2. 6C2 means 6 into 5 by 2 into 1. That will give you 15. 65 is nothing but 6C1. That's why it will be 6. Plus NCN is 1. So 66 is 1. That's why in total in how many different ways he can choose? 15 plus 6 plus 1. Totally it is adding up to how much? 22 ways. Hence he can choose the electives in total in how many ways over here? 22 ways. For more videos like this, please like, share and subscribe to our channel. Thank you.